Kia ora ngā hoa mā. On today's video we're going to be doing a little bit of reactive science. We haven't done much in a while. I've been very busy doing science experiments with basically the whole senior syndicate of my school. So those students that know me, we've been doing a lot of stuff around elephants, toothpaste and that kind of stuff. But what we're going to be doing today is I've done various experiments with a lot of the different classes, and one of the ones that the kids really like that never seen before is the fire extinguisher experiment, and that's what we're going to be doing today. So I'm going to show you how to make a fire extinguisher using a basic chemical reaction, and yeah, it's going to be really fun, and I hope you enjoy it, so stick around. So, in order to get our fire extinguisher to work, we're going to do an acid and base reaction. And I know that sounds all a bit scary, acid, but we're just going to be using a really basic mix or a solution made of citric acid. And so we're going to put our citric acid inside a plastic bottle. Now, the byproduct that we're trying to achieve to get the fire extinguisher to work is the release of gases, which also builds up to create a pressure. And so a plastic bottle is going to work fine for this. Now, you can use any plastic bottle, but the one that I probably wouldn't want to use, I mean, you could use any, like I said, any, but one that I'd want to avoid is a milk bottle. Now, it's not that it's going to explode or anything, it's just that the caps don't make a very good seal on milk. If you've ever stuck the milk in the fridge and you've light it on its side and the milk seems to dribble out of the cap, that's because it just doesn't have a very good seal on it. And if you think about it in a sense of we're trying to ensure that there's pressure within inside the bottle, the pressure will push the cap up and it'll escape out the side, and we want it to actually shoot out the end. So first things first, get yourself a nice plastic bottle. Doesn't matter what kind of bottle it is, although we do know it does. And take off the cap and just put a small hole. Now, you can do it with a drill. I just did this with something sharp, like a pair of scissors. You might need some parents' help for this one, guys. And just make a small hole. Don't make a massive hole, and it only needs to be about that small. So about the diameter of a pencil is big enough. Okay, if you go any further than that, it's probably not going to work very well. Okay, so the size of the diameter of a pencil or smaller. And that's all you're going to need to do to the bottle, and then stick it aside. So the next thing that we need to do is we need to make our solution. So you're going to get citric acid. You could use vinegar. I find citric acid works better. It's probably also a little bit cheaper, because mum and dad might want to use the vinegar for cooking. If you tell them to go to the supermarket and, "Mum, can you get me some citric acid for doing science experiments?" I just had a look up the road at the supermarket, and it's like $2.80, and you can get heaps and heaps of experiments out of one jar, whereas vinegar, you'll use that quite quickly. Because what we're going to need to do is we're going to need to fill this up about 2/3 of the way with our acid mix. So to this bottle, I'm going to add 2 teaspoons of citric acid and some warm water, and then give it a bit of a shake to mix it all together. So we'll come back in a second. So we've got our solution mixed up. Now, there's one other key component that I need to add before I go out and add the catalyst, which in this case will be baking soda. I'm going to add some liquid soap to it. Now, the liquid soap, like we've done in a lot of other experiments, helps to trap all those gases. But what I've found is, in this one, it slows down the experiment, but it also gives the reaction more volume. And what I mean by more volume, if we were to just stick baking soda into the acid, it'd probably just fizz and not really do anything, but we want it to kind of shoot out. So we're going to add some liquid soap into here, and like I said, it's going to create more volume because of all the byproduct of the gas getting caught in the liquid soap and making foam and bubbles. It increases the volume until it shoots out our nozzle, which is the hole. Okay, so there's no exact measurement for this. I like to add a healthy sloosh. Interpret that as you would. Okay. Now, any liquid soap's going to work, palm olive, anything. I'm just using a budget brand dishwashing soap, and you see there it's gone a bit yellow. I don't want to shake it. I don't want to shake it because I don't want it to start foaming until I've added my baking soda, and you'll see why. So stand by, we're going to go outside and let this off. Okay, so I've taken the cap off my bottle, and it's important that at this stage when you work fast, so because as soon as you add the baking soda you need to put the cap back on. Now because we've added the liquid soap, it's not going to react as fast. It takes a little bit of time. You'll see it start to reacting straight away, but I'm going to put the cap on and then I'm going to give the bottle a bit of a shake, and that's going to help really get the reaction going, and you'll see how much pressure comes out of the end of my nozzle. So you can see why that's the fire extinguisher experiment. It makes a jet coming out. The kids really like this experiment, so I'm sure that if you gave this a try at home, it's really fun. It's definitely worth buying citric acid over vinegar. You can see how much liquid is involved, and so if you were to do this over and over again, you're going to run out of vinegar really quickly. So I'd buy citric acid if I was you. But for now, if you like that video, hit like. If you like the channel in general, hit subscribe. But for now, ka kite anō, and I'll see you next time on Mr. Ashley's Place.